right, so we have 2015 free response question. And it gives a graph of a derivative, and that's the first thing you see. And everybody, you got to think to yourself, when you see graph of f prime, you got to be thinking fundamental theorem of calculus, all right? And it shows a twice differentiable function f. They give the graph of f prime. They give you the intervals here. Interval -3 to 4. All right, so be it. The graph has horizontal tangents at -1, 1, and 3. Everybody, I'm not even sure why they put that in the text outside to slow you down. That's obvious. All right. And then the question that's really hard to understand. The areas of the regions bound by the x-axis in the graph of f prime on the interval -2 to 1 and 1 to 4 are 9 and 12 respectively. All right. Everybody, this took me, I had to read this twice to understand what it meant. What it means is that the area in those two regions I just pulled out are 9 and 12. But everybody, we should recognize when we have an area under the curve, we really should think of this as -9 and -12, okay? But it didn't do it that way. It just gave the area of the region bounded, all right? So we have 9 and 12. And I'm going to leave at least the 9 and 12 up there underneath the curve for us as we do our problem. All right? The first one is find all coordinates at which f has a relative max. All right. If f has a relative max, guys, this simply becomes a problem on the first derivative rule. And we know the first derivative rule, all right, is that when f prime goes positive to negative, you have a local max. When f prime goes positive to negative. When we look at the graph, you guys should notice there were 3 zeros for f prime, 3 critical points. 2, 1, and 4, or -2, 1, and 4. But there's a sign change only at one spot. It goes positive to negative here. It has nothing to do with the slope. It has everything to do with the y value of these derivatives, all right? If I look on this side of -2, we have a positive value here for y. When I look on this side, we have a negative value. So the answer to this problem is simply that there is a local max or a relative max. A local max at x equals -2. And the reason is because f prime goes positive to negative. And everybody, that was 2 points on the AP. That is 2 points, all right? The position and the reason. And most of us got that, and that's good. I think we understood that. It's a fundamental theorem of calculus. We are just looking at the value, all right? Letter B. On what open intervals from -3 to 4 is the graph of f both concave down and decreasing? Give your answers. Okay, first thing I would do is write that decreasing, right? A decreasing function means f prime is less than 0. Everybody, you write that reason, right? We know a negative derivative is decreasing. And then this is the hard part again. You recognize this is a graph of f prime. So where is this graph negative? It's negative from -2 to 1, open interval, and 1 to 4. All right, that's awesome. The next thing I would write is they want to know where it's concave down. Well, what's the rule for concavity? Concave down happens when f prime prime is less than 0. Now this is much harder because you have to make the recognition at this point that you're looking at the graph of f prime. So how do you know the value of the derivative? Well, if I'm going to take the derivative of the derivative, I have to look at the shape of the curve. Negative slope here to 0. So this means here, this is f prime prime is less than 0. It is a decreasing. Here, it's going up. So this is f prime prime is greater than 0. Going down again here, f prime prime is less than 0. And up here, it's going up, f prime prime is greater than 0. So there are two regions on the graph that are concave down. -3 to -1 and 1 to 3. Guys, the simple question now becomes, where do these regions overlap? These regions overlap simply on, and I'm looking right here. I'm just looking at this point when I look for overlap. They overlap, so decreasing and concave down happens on -2 to -1. The overlap of these two regions. And over on this one, 1 to 3. If you can see that on the graph, I go back up. We agreed that this red curve, it was decreasing down there. The only places, again, you can catch it are here and here. It's where the graph of f prime is negative and going down. Okay? Again, that was worth 2 points. All right, and I do the intervals in notation on the AP. The answers were -2, like they were conjunction inequalities. Okay, doesn't matter which way you notate it. And they want reasons, and the reasons I gave were right there about f prime being less than 0 and concave down being less than 0, okay? The second derivatives. Letter C, find the x-coordinates of all points of inflection for the graph of f. Give a reason for your answer. All right, C. All right, first of all, you got to realize what points of inflection occur when f prime prime changes sign. All right, either positive to negative or negative to positive. Doesn't matter which, okay? So when I go back up to the graph here, again, you realize this is a f prime graph. You're going to look at the shape. So everybody, we kind of had that marked. I probably shouldn't have erased it. Here we have f prime prime is less than 0. Here we have f prime prime is less than 0 because those are decreasing parts of the derivative. Here, f prime prime is increasing, and here f prime prime is increasing. So guys, there are 3 points of inflection. There are 3 points of inflection. Right here, right here, right here. We have 3 sign changes on the second derivative. So it just asks for the x values, okay? So x equals -1, 1, and 3 RPIs. What's the reason? Because f prime prime changes signs. And everybody, that is, again, 2 more points. And these first 3, this would be my expectation. I mean, you should be pretty close on these. We should be able to find these. Again, this takes some practice. That's why we're doing the problems. All right? But that is the 3 points of inflection. Where I want to spend some time, what's not easy about this problem, no, none of this is easy, but what's really hard is letter D. All right? What's really hard in this problem is letter D. All right, so here's our graph of f prime. And then it says, given that f of 1 equals 3. And everybody, when they give you an initial condition, we should be thinking about the fundamental theorem of calculus. All right? And it says, write an expression for f of x that involves an integral, and then find f of 4 and f of -2. We have to remember that the fundamental theorem of calculus states that we can write this situation. If I want to find f of a, I can do that by having some initial condition Now, I'm going to say f of x. I'm sorry. If I want to find some f of x, I can do it starting at some initial condition plus the integral from a to x, where x is right of a, of the derivative, all right, t dt. And everybody, if you start to think about this, this is the fundamental theorem of calculus, all right? So we can find, anytime we know the derivative, we can find the function as long as we have an initial condition. And they gave us f of 1 equals 3. All right? So, and we know that the integral is the area under the curve. And I erased it, but we go back to the very beginning. They gave us that this area was 9 and this area was 12 between the curve and the x-axis. So if I want to find an expression here and I want to find f of 4, all right? I'm going to have to think of it this way. I'm going to write f of 4 is what I want to find. The only initial condition I know right now is f of 1. So I'm going to have to live there. Plus the integral from what? Well, now I know the integral has to go 1 to 4. From the initial condition to the value you want. All right? Of the derivative, f prime. And on our graph above, I can put it as t, but our graph above has x. I can use x, because that's what the value they put here. All right? And everybody, it's now just plug and chug time. All right? When I say that, what it is f of 1 is 3, and the area under the curve from 1 to 4 is 12. That's the area, but when it's underneath the curve, what is it? It is negative. So I find then that 3 plus negative 9, I know f of 4 is negative 9. And again, this is the fundamental theorem of calculus. This is section 5.3 in our textbook. We still have to find f of negative 2. This one's a little more complicated. It's still the same setup because we only know f of 1. And you still have to set it up. It still has to, the 1 still has to match. So you have to have the 1 on the bottom, but you got to go to negative 2. F prime x dx. Immediately, the thing you should recognize immediately is we do not put the small or the right limit at the bottom and the left limit at the top. We put negative 2 on the bottom and 1 at the top. And but we know we can do it if we switch the sign. Anytime we switch the limits of integration, we can switch it from positive to negative. And now we can do the problem, because the lower limit and the upper limit are in the correct places now. And again, if I go full screen, entire page, we know f of 1, that was a given condition of 3, minus, we know the area under the curve from negative 2 to 1 is, the area is 9, but it's below the curve, so it's negative 9. And I get f of negative 2 equals positive 12. All right? And that's the answer to these questions. All right? And again, this takes practice. All right? So we're going to do a lot of practice problems with this going forward. We only have a little bit of the textbook left. All right? This is what starts tying together all our rules.